Good morning. This recording is for Algebra 1, Chapter 9, Lesson 5, Factoring to Solve Quadratic Equations. And again, when we're trying to solve quadratic equations, just like Lesson 9, we're actually trying to find the x-intercepts. All right. Now in the last lesson, B in, let me see here, B in ax squared plus bx plus c was 0. In the last lesson, it was 0. This time, not 0. But we can use the zero property to determine zero product property to determine the x-intercepts for quadratic / parabola equations. Now, the zero product is basically based on the fact that something times something that equals 0, one of the somethings has to equal 0. Now, we use this kind of like Schrodinger cat sort of situation where both of them can be 0, but only one of them is actually going to be 0. But both of them could be 0. So since both of them could be 0, once we figure out what the value is that gets it to 0, we basically have our two answers. Both answers are possible, both answers work, but to get there, we kind of have to assume one of them is 0 at one point, whilst the other one is 0 at another point. Okay? So, what you do is you set each equation equal to 0, factor, then solve for the variables twice. And the solving for the variables twice is the easy part. It's actually getting to that part that's the hard part. All right? So the answer will not always be the positive, negative versions now since we have a b. Having a b means the axis of symmetry is something other than the y-axis. And remember to check your answer by plugging them back into the original problem, especially if you needed to factor to get your zero product in the first place. Okay, so again, back to this whole thing. We'll assume one of them is 0, so either x could be 0 or y could be 0. So if we have a factored problem here where we have the quantity x plus 3 times the quantity x plus 2 equals 0, one of them has to equal 0. In this case, x plus 3 could equal 0, and if x plus 3 equals 0, x equals negative 3. But the other one could also equal 0, because again, they have to get to the point where one of them equals 0, or both of them equal 0, hence the whole analogy to the Schrodinger cat thing. So if the second one, x plus 2 equals 0, then x would equal negative 2. Both of them would be then the x-intercepts of the same parabola, or quadratic equation, that if you were to graph that quadratic equation or then factor the quadratic equation to get this, those would be your two x-intercepts. All right, sorry, I have allergies, guys, so if you hear me sniffle, I'm sorry. Okay, so let's move on. So both x values make the equation true, and both are x-intercepts. Okay. So let's go ahead and take an equation that's already factored. And at this point, it's actually already set to 0. So we're going to solve each product, the problem in each set of parentheses, and those will be your x-intercepts. So we'll just set each set of parentheses set equal to 0. In this case, 6k plus 9 equals 0, and 4k minus 11 equals 0. And we're going to solve for k in each situation. So minus 9 divided by 6, k equals negative 3 over 2. Add 11 on both sides, k equals 11 over 4. All right? Now, if I were to check this answer, I'd kind of be going the long way about it since it's already been factored for me, but I would FOIL to figure out the original quadratic equation, and I kind of cheated and I just stuck it into SciGraphCal, and I figured out where the x-intercepts were to check my work. Okay? Yes, technically, you can cheat using GraphSciCal on this, which is why I'm going to really be strict about checking work. You have to be able to show me this, guys. If you can't, I'm not going to believe you did the work on your own and instead got GraphSciCal to do all the dirty work for you. Okay? But you got to be able to do this without GraphSciCal, because you got to know what GraphSciCal is doing in order to get the answers. Okay? All right, let's move on. So again, the reason we set the equation or quadratic factor of the quadratic to 0 is because y needs to be 0 to get the x-intercepts. Okay, makes sense? Because again, this is the point negative 1/2, 0, and this is the point 11 over 4, or 2 3/4, 0. Okay? All right, let's move on. Okay, so again, You can also use the zero product property for ax squared plus bx plus c equals 0 if it can be factored. Remember, the quadratic equation must equal 0 for the zero product property to work. So let's go ahead and take a look at a quadratic equation. It's already set to 0, so there's not much we have to do besides factor. So let's go ahead and factor this. We have basically 1, -8, and -48. You guys should know how to factor by now. You figure out how the factored works. You create your binomials. Since the product of the two binomials is equal to 0, we set both binomials equal to 0 and solve for x in each case. Well, there you go. So the two intercepts for this equation for this are 12 and -4. Make sense? Good. Now, again, you can always go in and check your answer. And you should be able to do this by plugging each back into the original equation and get a true statement out. So let's go ahead and plug in 12 into the original equation, and see if we get a true statement. We do! 12 squared is 144, -8 times 12 is -96, minus 48, 0 equals 0. So 12 works. Woohoo! Now let's try -4. There we go. Hey, it works. Awesome. And again, I expect to see a lot of work on these, since graphing apps can do the work for you. So no cheating, and that's the smiley face of no cheating. Now, you could always use GraphSciCal to check your work, but I want to see all of this on your actual paper, okay? Well, actually, I take that back. I want to see all of this on your paper. This is just checking, okay? And this, again, you can do on GraphSciCalc. Okay, you get the idea, right? Okay, moving on. All right, so let's do another problem. Actually, let me erase this artifact over there. All right, let's do another problem. X squared minus 12x equals -36. This is not set to 0 yet, but that's okay. Let's go ahead and set it equal to 0. All right, set equal to 0 by getting all values on one side of the equal sign. So there you go. I moved over 36, and now it's over with the other stuff. Now, to get the zero product property, we need to factor this. All right, and I'm going to factor it, blah, blah, blah. Moving on, figured it out, works out. All right, so there are my two binomials. All right, and it's set to equal to 0, so therefore I'm going to solve for x. But Miss TH, those two binomials are the same. Yes, they're the same. If they're ever the same, that means you only have one solution. One solution means that the parabola will only hit the x-axis at one point. Therefore, only one solution, and that solution is 6, 0. Pretty cool, huh? Okay, let's move on to something crazy. Suppose that a box has a base with a width of x and a length of x plus 1 and a height of 2 inches. So basically, let me draw out what this kind of three-dimensional box looks like. It kind of looks like just like a turn your work in tray that doesn't have a lid, okay? No lid, all right? And this box has a width of x, a length of x plus 1, and a height of 2. All right, so we've got this three-dimensional box that actually doesn't have a lid. Okay, can you guys visualize that now? Good. Well, we're going to cut this box from a rectangular sheet of material with an area of 182 inches squared. And we're going to try to find the dimensions of the box. Well, we know already that the height is 2, so that's actually one of the 3 dimensions. And again, a three-dimensional object has 3 dimensions. You guys got that right? 3 dimensions. 3 dimensions. And we already know one of them is 2, but we need to figure out what x and x plus 1 is. All right, so let's go ahead, and now that we've drawn the three-dimensional box, let's go ahead and draw the rectangle that this thing is made out of. There we go. All right, so the big black box, the bigger black box, has an area of 182, and we know that we're going to basically cut out these little squares that are 2 by 2, and then we're going to fold up the edges to make the box. All right? So there you go. So we're cutting out these little 2 by 2 squares on each corner, and we're just going to fold them up. It's basically made out of cardboard or something pliable because we want to make a three-dimensional shape out of something that was flat. So here's what we're going to do. The length, excuse me, let's talk about the width. The width of this rectangular piece of cardboard is x plus 4 because it's the two edges plus the x. Got that? Okay, so that ends up being that the width of the entire piece of rectangular cardboard is x plus 4. Now let's talk about the length. Well, we know the length is the two we're cutting out plus the x plus 1. So that ends up giving us x plus 5 as the length. So, and as you remember back from probably like 5th grade math, length times width equals area. All right? So if I take the length and the width and multiply them together, in this case x plus 5 and x plus 4, it equals 182. But Miss DH, we can't do zero product with this. No, you can't. So the very first thing you're actually going to do is you're going to FOIL. FOIL, first thing you're going to do is FOIL, because we want to get this back into kind of a regular looking equation. And then we need to get this set equal to 0. All right, set equal to 0. So we're going to minus 182 on both sides, and we're going to get x squared plus 9x minus 162 equals 0. Now we need to do zero product property, which means we need to go back and we need to factor. Yes, 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 this is all pretty crazy, huh? So there we go. So when we factor this, we're going to get x plus 18 equals times x minus 9 equals 0. And then we're going to solve for x using the zero product property. Well, x plus 18 equals 0 means x equals negative 18. And when we have x minus 9 equals 0, we have x equals 9. The thing is though, one of these answers doesn't work. And that's when this whole real world situation comes into play, and you need to pay attention to it. You can't have a negative dimension. My box is not negative 18 inches long, or wide, sorry, because x equals negative 18 wouldn't work. It wouldn't work, right? So negative 18 is actually not the answer. Negative 9 is, x equals 9. So if I set x equal to 9, I'm going to get x equals 9, and then I'm going to, as the width of the box, right? So if I'm like up here, x equals 9, and since x still equals 9, we're going to have 9 plus 1 equaling 10, so that would be the length of the box, the width of the box, and we already knew the height. So the final dimensions and final answer would then be 2 inches by 9 inches by 10 inches is the dimensions of the box that I was able to then cut from a rectangular piece of cardboard that had an area of 182 inches squared. I hope your minds are blown. I love this problem, but it's definitely one of those, oh my gosh, how many possible steps could I possibly do to get these answers? All right, hope you guys are good. Talk to you later. Bye.